So yesterday we worked on how do we solve equations using factoring. Today we're going to apply this even further by representing a word problem with an equation and then solving it with factoring. So here is the first problem we are going to solve. Let's read it together. Penny is a fox terrier who competes with her trainer in the agility course. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by the situation h equals negative 16t squared plus 20t, where h is the height of the leap in inches at t seconds. Find the values of t when h equals 0. So let's kind of break that down a little bit and see what we have. So first of all, we're talking about a dog jumping. So we can imagine a dog jumps something like this. And to figure out the height of the dog, we can use this equation here. So after t seconds, we can figure out the height, how high off the ground Penny is at any time. So we are going to be using this equation. It tells us h equals negative 16t squared plus 20t. So then we need to figure out at what time is Penny's height 0. So in other words, at what time, after how many seconds, is she on the ground? She has no height off the ground. She's just on the ground. There's no height. So what we can do is it tells us h equals 0. So we will change this this h, we'll make it a 0. And then we want to figure out what values of t would make the height be 0. So we're going to solve this equation for t. Since we have this exponent here of a 2, we are going to solve this by factoring. So I'm going to factor this polynomial here. First step always is to see what do they have in common. Both of these can be divided by 4, and they both have a t. Now we are going to solve this equation just like yesterday. We are multiplying the outside times the inside. So either this outside portion will equal 0, or the inside portion will equal 0. And we can solve to get t from here. So in this last step, since I have a negative divided by a negative, it would just be a positive, and it doesn't completely divide, so it stays as a fraction. So to answer the question, the values of t when h is 0, so when Penny is on the ground, either 0 seconds have passed or 5/4 seconds have passed, which makes sense. Obviously, when she hasn't even started jumping, no seconds have started, she's on the ground. And then in 5/4 of a second, she will be back on the ground again after completing her jump. So these would be our 2 answers for this problem. All right, next up, let's take a look at this problem. The height of a parallelogram is 6 centimeters less than its base. If the area is 16 square centimeters, what are the lengths of the base and height? So this problem is asking us to find an area of a parallelogram, the height, the base. So since we're talking about a shape, I think it's helpful to draw a picture to help us understand what it's asking. So this is a parallelogram. If you don't remember that, you should probably refresh your memory on what's a parallelogram. So then from here, this length is the base, and this is the height. So when we're finding the area of a parallelogram, it's actually just like how we find the area of a rectangle or a square. The area of a parallelogram equals the base times the height. So then we can use the information we're given to figure out the different measurements, the area, the base, the height. So it tells us that the height of the parallelogram is 6 less than its base. So this is where we use the what we learned earlier in the year about representing situations with equations. So for this part here, I can represent this by saying the height is, or equals, 6 centimeters less than its base. Less than, hopefully you remember, this is a key word that tells us we need to switch the direction, meaning it's going to be b minus 6. So then filling this in to this equation, we also know that the area is 16. So instead of a, I'm going to put 16 equals b times, and then now instead of h, I know that h equals this, b minus 6. So I'm going to substitute in b minus 6. Now at this point, we are trying to figure out how much is the base and how much is the height, how many centimeters. So we can solve this equation here to see what would be equal, and then use that to find our height as well. So since we're talking about factoring, let's first simplify this expression, get everything together here to make it like an equation that we were doing yesterday, where we had a variable squared and then it equaled 0 in the end. So the first thing I need to do in order to get this variable squared is to actually multiply this out. B times both terms inside the parentheses using the distributive property. So then this would be 16 equals b squared minus 6b. Next, we want to get the one side of the equation to be equal to 0, so we can use the 0 product property. So that means I need to cancel out this 16 and bring it over to the other side. So I'm going to do minus 16 on both sides of the equal sign. Cancels. Here, I'm going to continue my work up here where I have more space. So we'd have 0 equals b squared minus 6b minus 16. Now that we have a variable squared, we have it equals to 0, now we can go ahead and factor this to solve. So there's not one term in common that can divide into all 3 terms. There's not one common factor. And there's not a number besides the invisible 1 next to the b squared. So I'm going to factor this trinomial by looking to see what 2 numbers multiply to negative 16 and add to negative 6. So 1 times 16, no. 2 times 8, yes. 1 will have to be positive and 1 will have to be negative. So in order to add to the negative 6, I'm going to need a negative 8. All right, so then either this parentheses could equal 0. So then b would be equal 8. Or this parentheses could equal 0. So now we have 2 possible answers for what the base could be. In this case, since we're talking about a real world situation, we need to see what actually makes sense in the context of the problem. If we're talking about the length of the base here, it doesn't make sense for there to be 2 different length measurements. This is only one possible length. And also, it's not possible to have a measurement of negative 2 centimeters. You wouldn't measure the length of a shape and get negative 2 or negative anything. Measurements are always positive when we're talking about side lengths of a shape. So what we do in this situation is, in a real world situation like this, we need to see which one makes sense, and we won't necessarily have 2 answers. So in this situation, only the b equals 8 makes sense, because that's the only positive one, and only a positive answer would make sense when talking about the length of a side of a shape. So when it asks us about what is the length of the base and the height, we know that the base is 8 centimeters. Then using this, we can solve to see what would be the height. So we know that the height is 6 centimeters less than its base. So using this equation, now we know that the base is 8, and the height is going to be 6 centimeters less than that. So the height is going to equal 2. So in this case, the height is 2 centimeters, and this is your final answer. All right, here is the last problem we are going to go through together. So let's go ahead and start reading it. A model for the height of a projectile is given by h equals negative 16t squared plus vt plus h sub 0, where h is the height in feet, t is the time in seconds, v is the initial upward velocity in feet per second, and h sub 0 is the initial height in feet. Ken throws a ball that follows the equation h equals negative 16t squared plus 38t plus 5. I know that sounds wordy when we're first reading it, but if we break it down, it's not too bad. Maybe you've used this equation before in science. This is a really common equation used in physics. It's a universal equation used all the time. So we're talking about the height of a projectile. A projectile is anything that you throw. So we're talking about what's the height of something thrown. And so it's like that first problem with Penny the dog, where we're looking to see what is the height of Penny after t seconds, or the height of anything generally thrown after t seconds. So this variable in the equation h, it's talking about the height in feet. The t, it's the time in seconds. The v, it's the initial upward velocity in feet per second, meaning it's how fast is it going up when it's first thrown. And then h sub 0 is the initial height in feet, meaning how high do you throw it from? Do you throw it from 0 feet on the ground? Do you throw it from 10 feet up on the second floor of a building? It depends on how high you start by throwing the ball. So that's breaking down each variable. Now it gives us the equation for Ken throwing a ball. So in this case, it tells us that the initial upward velocity is 38. So that's how fast the ball is going from the beginning, 38 feet per second. So when it says what is the initial height of the ball, let's see which one of these variables tells us the initial height of the object. Here we have h sub 0. So which one of these here would be in the place of h sub 0? Hopefully you said the 5. So it's talking about the height in feet. So the initial height is 5 feet, meaning Ken is probably standing up and throwing this from a standing position. So his arm is 5 feet off the ground when he starts throwing the ball. Okay, so then B, after how many seconds does the ball hit the ground? Hint, what is the height of the ball when it is on the ground? So when the ball has reached all the way down to the ground, what is its height? Is it any feet off the ground or no feet off the ground? Once it hits the ground, it has no height. It's at 0. So we're looking to see when is the height 0. So when it hits the ground, this means that the height is 0 feet. So we're going to use this equation, but now instead of h, I will put 0. And now we'll solve this equation to see what would t equal. First step, do we have a common factor? We can divide 5 by 5, but we can't divide 38 by 5 or 16, so nope, there's nothing in common, meaning we're going to have to factor this, and specifically we're going to have to use the AC method this time to factor because we have a number here, a coefficient next to the t squared. So getting started with this, AC, negative 16 times 5. 5 times 1 is 5 plus 3, 8. And it's negative times positive, so it's negative 80. Now I'm looking for two numbers that multiply to negative 80 and add to positive 38. So you can start checking to see which one of these adds 38. Hopefully you've already found it. 2 and 40. Since we're multiplying to equal negative 80, one will have to be positive and the other will have to be negative. So to make a positive 38, we should have a negative 2 and a positive 40, since those will add to make positive 38. So now I will rewrite this equation, but this time I'm going to split up the positive 38t into a positive 40t and a minus 2t. Then we will continue factoring with the AC method. So both can be divided by 8, and they both have a t. In the next parentheses, the only common factor they have is a 1. They both don't have a t, so I can just factor out a 1. Then I'm noticing both parentheses are the same, so I will factor that out since it is in common. Then I'm left with an 8t and a plus 1. All right, all that, now we have this factored, so now we can finally solve this equation to see after how much time does the ball hit the ground. So first, I will solve this one. If this were to equal 0, so negative divided by negative is going to be positive, so 5 over 2 seconds. Then here, this one could equal 0 as well. So in this case, t would equal negative 1/8. Okay, so now that we have our two answers, let's see if they make sense. So our unit that we're talking about with t, it's the time in seconds. So we're throwing a ball and we want to know after how many seconds does it hit the ground. So our options are 5/2 seconds or negative 1/8 seconds. If we're talking about seconds, does it make sense to have negative 1/8 seconds? Could we go back in time throwing a ball? No, it doesn't really make sense for this. So in this case, only this answer, the positive one, this is the only one that makes sense. So that's going to be our answer for this question. So after how many seconds does it hit the ground? After 5/2 seconds. So you'll notice that when we're working with real world problems, even though we get, and we should get, two answers to the problem, a lot of times only one of them is going to be the actual answer to the real world situation. So you're going to have to kind of think about what makes sense really in this situation. Does it make sense to have negatives? Would it be better to have positives? So even though you get two answers, what will answer the question might only be one possibility. So that's all for that. The practice, it's similar problems to this, so you can go ahead and get started on that. Let me know if you have any questions.